All right, so first section we're going to look at this week is called the law of sines. Okay, as I said, we're going to split it into 2 days. So with law of sines, there's several different cases you can do. We'll do a couple of them today, and then we'll save one of them for tomorrow. Okay, so I mentioned that a couple weeks ago we did problems where all the triangles had a 90-degree angle. Okay, and then when you have a 90, it's called a right triangle. And you can use Pythagorean Theorem, and you can also use SOHCAHTOA, like opposite over hypotenuse, adjacent over hypotenuse, tangents opposite over adjacent. Well, if you don't have a 90-degree angle, you can't use any of the stuff I just said. Okay, and there's a name for the type of triangle when it's not a right triangle. Okay, that's called an oblique triangle. And there's really 2 different types of oblique triangles you can have. You can have an acute triangle. That's where all the angles are less than 90. As a specific example of an acute triangle, think of like an equilateral triangle. Let's try this one. Okay, that's an oblique triangle. Specifically, it's an acute triangle. Okay, or an obtuse triangle. Okay, that's where one of the angles is bigger than 90. How come you can't have 2 angles bigger than 90?
Because then you won't get 180.
Right, then they wouldn't add up to 180. It would be more. Okay. So as far as sketching, we don't really have to sketch things accurately. We're more going to draw a picture so that we can see what is across from what. So in general, when I sketch a picture, I always do it this way. And then I just label my sides A, B, C, and I'll talk about what we name the angles. Okay, you should already hopefully remember 2 of the names of the angles. It's the Greek letter for A and the Greek letter for B. But we got to come up with a 3rd name because we never had to name that angle. That was always the 90, so we just called it the 90. Well, now it's not. So we'll give that a Greek letter name as well. Okay, and here's the diagram that we're going to use. Okay, so A, B, and C are still the sides. And does anybody remember the name of the Greek letter that's across from A? Yep.
Alpha.
Yep, alpha. And the Greek letter that's across from B? Yep, that beta. And now where we had the right angle, we're going to call that another Greek letter. It kind of looks almost like a Y. Maybe a bird flying off into the sunset. Whatever you want to imagine it as. And that's the Greek letter gamma. Now, I think I mentioned this when we did this with right triangles, but why not just use like capital letters for the angles and lowercase letters for the sides? Anybody think of what kind of confusion might happen there if we did that? Yep.
If you mislabel one of them as a capital instead of a lowercase, then it gets all messed up.
Okay, so you might mix up your labels because you're using like the letter A for both a side and an angle, just trying to remember which one's capital. This way it's very different. A Greek letter and an English letter. Anything else about capitals and lowercases? Especially with certain letters?
Same.
Yeah, they might look the same. So if you write down especially C, it's really hard for me to tell out of the context of like a sentence, is it a capital C or is it a lowercase c? So we're going to stick with English letters for the sides, Greek letters for the angles. Okay, just like last week. And always keep this relationship. A across from alpha, B across from beta, C across from gamma. If you want to draw your triangle differently, that's fine. Just keep the relationships I just said. Okay, anybody remember how many pieces of information you have to solve a triangle?
2. No, 3.
Yeah, you always have to have 3. Okay, last week I only had to give you 2 because you always had a 90. So the 90 counted as 1 piece of information, and I gave you 2 other things. Well, it's going to be the same idea this week. I'm going to have to always give you 3 pieces of information out of the 6. Okay, and one case I could give you is when I tell you two of the angles and a side. Okay, and even doing it that way, there's two ways I can do that. I can give you two angles, and then I could tell you the side that connects them, the side that's between. The diagram on the left is a picture of that. You've got two angles, and you know the side that connects the two, the side that's between. Or I could give you two angles and give you the side that is not between them. Okay, so for example, I gave you the angle at the bottom, another angle at the bottom, and the side on the left. Okay. The side on the left, the one that's 4 units long, it's not the one that's between the two angles. So we're going to use this naming, okay, this lettering, three-letter notation. It's the same notation you use when you do proofs in geometry. We're not doing proofs with them, but it's just to identify what information we have, okay, and where it is. Okay, so two angles and a side. That's one type we'll look at. And the other type is two sides and an angle. Specifically where you have two sides and the angle not between the two sides. Either angle, not between the two sides. Okay, so I've given you a side, and then the angle I gave you is not the one between the two sides. Okay, the one between the two sides is in the top here. Okay, and when you write the three letters, okay, describing the kind of triangle you have, you can write it forward or backward. Like if you write angle, angle, side, that's okay. Okay, it's the same as side, angle, angle. ASA, if you want to write that backwards, go for it. The bottom one, I'd prefer you to write it in this way. It's just a little more polite. Don't write it backwards. All right. So any questions on those three types we're going to solve? All right. So you might notice there's a couple missing here. This one's not up here, where you know two sides and the angle between it. And this one's not up here, where you know three sides. That's because the law that I'm teaching you today and tomorrow, you can't solve with this law. Okay, there's two laws that we're going to study. Law of sines. Anyone have a guess what the other law is? Cosines. Law of cosines. Law of cosines, that's where these two come in. Okay, that'll be on Wednesday. Okay, but if you have any one of these three types, angle, side, angle, angle, side, angle, those three types are law of sines. So on the test, that's the first thing you have to figure out. Okay, when you have a problem, should I use law of sines or should I use law of cosines? And you don't really have a choice. If you try to use the wrong law, it won't work. So, but if you want to, have a list, these are the three that you use with law of sines. Those are the two with law of cosines. All right, so leave a little bit of space. We're going to write down what the law of sines is in a second. But first, I'm going to show you where it comes from, okay, based on what we did the week before graphing. Now, the law of sines has three parts to it. Okay, I'm only going to show you the first two, okay, where they come from. You could easily do the third part by repeating exactly what I'm about to do again. Okay, but we're not going to repeat it. So we're just going to show you where the first two parts come from. And in order to do that, we need this diagram. Okay, so leave a little bit of space under that, because we're going to write the law of sines in a second. Probably only need to leave 2 lines. It's not that big of a formula to write. And then below that, we'll look at the proof. Okay, does anybody still need what's on the left? So I can make the right bigger? No? Okay. Okay, so I've drawn an oblique triangle. And I didn't label all the sides in it because I don't need to use all the sides in this problem. I just labeled 2 of the sides and 2 of the angles. So just label A and alpha, and then B and beta. Okay, and then once you have this triangle, what I want to do is take and draw in a vertical line from that angle straight down to the base. Okay, what did I just create by drawing that vertical line? I had one big triangle. Now I just created, yeah? 2 smaller triangles. And can you tell me specifically what kind of triangles I made?
Right triangle?
Yeah, I just made 2 right triangles. Okay, and the height of each triangle is right there. Okay, so just call that the height. Okay. What I'm going to do is I'm going to focus on the left triangle first, and then the right triangle second. Okay, so I'm going to cover up the right-hand side. Okay, so let's just focus on what's on the left. All right, and what I want to do is come up with a relationship between alpha, h, and b. Okay, and it's a right triangle. So first thing I'm going to do is just figure out the names of these 2 sides relative to that angle. Okay, what's the side that's farthest away called?
Opposite.
Yeah, that's opposite. And the name of the side always across from your 90? Hypotenuse. Opposite and hypotenuse. So out of all the trig functions we studied last week, sine, cosine, and tangent, one of them is this, sine. So it's always sine of your angle equals opposite over hypotenuse. It's a little confusing. I think with h, maybe that's not a good letter to use. I'm using h for height, but we also have hypotenuse. So just to be clear on that, b is the hypotenuse, h is the height.
Could you relabel them H and C? Or A
I
and
could,
C?
yeah. I'm just going to stick with these letters, but yeah. Right, so sine is opposite over hypotenuse. And now I want to get h by itself. Okay, so how would I move b to the other side?
Multiply by B.
Multiply by b. Okay, so multiply by b. And multiply by b. Okay, so now it says b sine alpha equals h. Okay, and that's all I'm going to do with that. I'm going to stop with that for now, and I'm going to jump over to the other triangle now. Any questions on that? So we just calculated a formula for the height. It's b times the sine of the angle. But we don't know b and we don't know the angle, so we can't really do anything with that. All right, so let's take a look at the other side. And I'm going to do the same thing again. Okay, I want to come up with a formula involving my angle, the height, and the hypotenuse. Okay, I'm going to ask the same 2 questions. What's the name of the side that's farthest away from my angle? It's opposite. And what's the side across from the 90? That's my hypotenuse. Which trig function has those 2 sides in it? Sine. It's the same function as last time. So sine of my angle equals, what was the side that's opposite? H. And what is the hypotenuse?
A.
A. And I'm going to do the same thing I did last time. I want to get h by itself. So what would I multiply each side by to do that? A. So that's gone. And I get another formula for the height, different than the first one, but still equal to the same height. So another way to calculate the height is to do a times the sine of beta. Okay, but both of those boxes will give you the same answer. If you do it the way on the left, you get the height. If you do it the way on the right, you get the height. So what else could I say here? If box 1 is equal to the height and box 2 is equal to the height, that means something else. Box 1 and 2 are both equal to the same thing, which means what? Dan? I have the same amount of money as you, and I have the same amount of money as Jesse. So what else does that mean? No? Yeah? What's equal? Yeah, the two formulas have to be equal. Right? If I have the same amount of money as one person and I have the same amount of money as a second person, then those two people must also have the same amount of money, right, as each other. Right? If box 1 is equal to the height and box 2 is equal to the same height, then box 1 and 2 are equal to each other, okay? Because they're both equal to the same thing. So B sine alpha is equal to A sine beta. Okay, and now what I would like to do is get A and alpha on the same side. So I'd like to put the A on the left, and I'd like to get B and beta on the same side. Just because in the picture, those are the ones we usually put across from each other. So how would I move A to the left side? Yep, Sam? Divide by A. And at the same time, how would I move B to the right side? Divide by B. So I'm going to divide both sides by AB. What's going to happen is that's going to cancel. That's going to cancel. And that cancels. And that cancels. So now I get sine of alpha over A equals sine of beta over B. And those are the first two parts of the law of sines. Okay, so where I told you to leave a little bit of space, this is what you're going to fill in for law of sines. It's sine of alpha over A, which is equal to sine of beta over B. And there's a third fraction. Anyone have a guess what the third fraction is going to be if it follows the same pattern as the first two? So it's going to be sine of something. Yeah, sine of gamma over C. Okay, that's the third part of the law of sines. I'm not going to go through the proof of why this one is true. So we didn't prove this one. Hey, but you could prove it by drawing a diagram just like I had up above. And instead of using the upper left and the upper right sides, pick two other sides and do the problem again. Pick the upper left and the bottom side. Okay? And draw your height from a different angle. Don't draw it from the top angle. Okay, but that's your law of sines. Now, whenever we use the law of sines, we only use 2 out of 3 parts of this equation. You're either going to start with the first 2 parts, the last 2 parts, or the first part and the last part. But you never use all 3 parts at the same time. Okay? All right, so we've got the law of sines. Another thing we're going to do, which you guys are already used to from 2 weeks ago, we're going to make a table to organize all our information. So in the table, what we'll do is we'll put the 3 sides in one column and the 3 angles in another column, just like this. Okay, so that's how we'll set up our table. And since we don't have a right angle, can we use Pythagorean Theorem? Nope. But we can still use the fact that if you add up all the angles in the triangle, they should add up to how much?
180.
Yep. they still add up to 180. Okay, so that's still true. Okay, so as far as formulas go, you have every formula you're going to need up until Wednesday now. Okay, this formula will solve pretty much the first half of the entire test. Okay, the only thing left to do is just to practice some of the different examples. Okay, so what we'll do is we'll go through one of each type. Okay, we'll do an angle, side angle, and side angle. All right, so sometimes when they give you the problem in the book, they'll show you a picture, and then it's a lot easier to see what one of the three types you have. If they don't give you a picture, you need to make a picture yourself. Okay, the only reason I want to make a picture is because that's going to help me to figure out, should I use law of sines on this problem, or should I use law of cosines? All right, so I got my table set up. A, B, and C in one column. Alpha, beta, gamma in the other. I put boxes around everything I need to find. B, C, and gamma. Let's make our picture just off to the side, just so I can see what kind of problem it is. So they told me A, and they told me alpha. So put those across from each other. They didn't tell me B, but they did tell me beta. They didn't tell me C, and they didn't tell me gamma. Okay, so all I did was plug in the information they gave me into this picture. All right, so focusing on the three pieces of information they gave me, what kind of triangle is this? Using those three letters. Let's see. How about Marquise? Can you tell me what?
It's in a obtuse triangle.
So right, it is going to be obtuse. I agree with that. But how about using the three letters, like the S's and the A's?
Oh, it's angle, side, angle.
Not quite. This one's not angle, side angle. To have that, you'd have to know side C. That would be the side that connects the two.
Angle, angle, side.
Yeah, this is angle, angle, side, because the side that you know does not connect. It's not between the two S's, or the two A's. So this is angle, angle, side. Or you could write side, angle, angle. Same thing. Okay. Any questions on that? Okay, that's one of the most important steps, because now, because I know it's that type, you can go back in your notes, and that is one of the three types you should use law of sines for. Okay, so now we know the formula we should use to solve it. Okay, another quick way you can tell that you should use law of sines is if you set your table up correctly, just like I've shown you. If you have a row that has everything in it, that's a law of sines problem. Okay? If you have a row with everything in it, that's a law of sines problem. So maybe you can see why, if you knew a side, and a side, you wouldn't have a row with everything in it. So we couldn't use this law. All right. So now what we're going to do is start with the row that has everything in it, and we're going to plug that into the law of sines. Okay, so the law of sines says we have sine of alpha over A. Fill in everything you know into this part. Alpha is 40, A is 4. Okay, so we've got sine of alpha over 4 equals. And for now, I'm going to ignore the third row. I could have found gamma right away. I can come back and do it in a second. It doesn't matter. But I'm going to find b first. Okay, so if I'm going to find b, I've got to use the information from row b. And we're going to use the second part of law of sines. Right, so you filled in the first part, sine of alpha over a equals sine of, what's beta? 60 divided by b. If you set up the law of sines correctly, when you're done, you should have 3 numbers and 1 letter. If you ever end up with 2 letters, something's wrong. Like if I had tried to do the bottom row right now, there's 2 things I don't know. Okay, so that's not something I want to do yet. Okay, does anybody remember what you call this when you have a fraction equal to a fraction? Begins with a p. Yeah, it's a proportion. And how do you generally solve a proportion? What do you do? Yeah, all you have to do is cross multiply. So we're going to do b sine 40 equals 4 sine 60. Okay, so just cross multiplied. And now my goal, get b by itself. Don't calculate any of these numbers yet, okay? Because I don't want to round anything off till the very last step. Okay, so I don't care what the sine of 40 is yet, and I don't care what the sine of 60 is. We'll do that at the end. So how would I get sine of 40 on the other side? So b's by itself.
You divide it.
Divide by sine 40, and divide by the sine of 40. And we need to type that in. Okay, everything that we do this week is going to be in degrees. Okay, so if your calculator is in radians, you can change it to degrees, and you can leave it in degrees for every problem we do this week. Okay, and type it in exactly the way you see it. 4 sine 60 divided by sine 40. All right, and I know something's wrong because I'm calculating the length of a side, and I know what's wrong. But how did I look at that answer and know something was wrong right away? This is the length of a side in a triangle. It's a negative, right? So the first thing I looked at was my mode, and I did what I told you not to do. So put your calculator in degrees, and type it in. Okay, so we get 5.389. Okay, be very careful if your calculator is like this and uses parentheses, because if you forget to put in that parenthesis like I did after the 60, you get the wrong answer. All right, so check your calculator however you type it in. Make sure when you're typing it in, you get 5.389. If you're getting something different, your calculator's in the wrong mode or you're not typing it in correctly. Okay. All right, so now we've got B. What could I find pretty quickly? And I could have found this right away if I wanted. Sam?
Gamma.
Yeah, I can get gamma, and I could have done it right away because I know all the angles have to add up to 180. So Sam, what's gamma?
80.
Yep, 80. Okay, so that was a quick one. Any questions on how I got gamma? Okay, so Katrina, what's the last thing I have to find? C. So last week when we solved triangles, did you use something that you found to find something else? No. Why did I say don't use things you calculated to find other things? It could be wrong. Well, this week we have to do that. Okay, there is no way to find C without using gamma. You have to. So if you make a mistake with gamma, you're going to get C wrong automatically. you could still get B right. All right, so B has nothing to do with C. But if you get gamma wrong, you're going to get C wrong. Okay, so you got to be very careful this week. So just don't make a stupid arithmetic mistake and write 90 or something for gamma. All right, just double check it, make sure that it all adds up to 180. Right now we'll find C. Now I have to use a row that has everything in it. I've got 2 rows that have everything in it now. You think I should go back and use the first one or the second one? Yeah, I'd use the first one because at least we know if we use that, everything is right. Okay? If we can avoid it, we'll try to avoid things we calculated when we can. So let's set it up just like we did before. Sine of 40 over 4. Okay, except what's going to go on the other side this time? Sine of what over what? Sine of 80 over C. Okay, and after you've done a lot of these problems, the cross multiplying, you can almost start to do it in your head. So I'm just going to show you how that works now. You're going to have to do 4 times the sine of 80 and then divide by the sine of 40. If you want to show out the cross multiplying every time, you can. But that's exactly what's going to happen if you do. 4 times the sine of 80 divided by sine 40. Okay, any questions on that? All right, so let's type it in. Okay, before I type it, I just want to get an idea of what kind of number I should expect. Gamma is the biggest angle, so this should be the biggest side. So I should get a number bigger than 5.389. But it can't be bigger than the sum of the other 2 sides. Okay? In any triangle, if you add up 2 sides, it always has to be bigger than the third. So it can't be bigger than 9.3. So it's got to be between 5.389 and 9.389. If it's not, something's wrong. All right, so we'll type it in. For sine 80, what do I got to make sure I do after the 0? Yep, if you don't, it'll come out wrong. Okay, and then divide by sine 40. I don't have to close the parenthesis after the 0 if I don't want to, because there's nothing else coming after it. But because I have OCD, I'm going to close it. So we get 6.128. And that's what I expected it to be between, somewhere between these 2 numbers. All right, so biggest sides across from the biggest angle, smallest side is with the smallest angle. Things look good. Now, if I wanted to double check my answer, can I use Pythagorean Theorem and do a squared plus b squared, see if it equals c squared? No, why not, Jake? I don't have a right triangle. Okay? If you try to do Pythagorean Theorem, you're assuming this was a 90 and it wasn't. So Pythagorean Theorem won't work to check your answer. Okay? Right, and that's how you solve angle side. Any questions on that type? I'm just going to do 1 of each type today. So there's three problems we're going to look at. That's the first one. All right. Second one. This time it's a little easier to see the type of problem because they gave you a picture rather than a description in words. Okay, what kind of triangle is this using the 3 letters to describe it? This is an angle, a side, and an angle. Okay, so you know 2 angles, and then you know the side that's between them, okay, or the side that connects the angles. Any questions on why this is an angle side angle? is this one of the three types I said that you use law of sines for, or is this law of cosines? Yeah, this is a law of sines problem. If you go back and look at your notes when I told you that, it is law of sines. Okay, regardless if it's a law of sines or cosine problem, you're always going to set up your table just like this. Now, does anybody remember the other trick I told you? How you can look at the table and know that this should be a law of sines problem or not? What can you look at in the table? Yep.
The positions, like angles. Like if you have two angles in a side, it's a law of sines.
So I'm thinking more along like looking at a row. I said something about a row in the table to tell if it's law of sines. Yep.
There's a complete row.
Right, if there's a complete row. Now, technically I don't have a complete row, but could I get a complete row pretty easily? Yes. I have two angles, I can find the third one, and then I would have a complete row. So this is going to be law of sines. Okay. Let's get that right away, because in this problem you can't do anything until you find gamma. You have to get gamma first. Okay. So what is gamma going to be? 95. Okay, just take 180 and minus the other two. 95. Now, this time it's even more important that you get gamma right than the last problem, because you're going to use 95 degrees to find B, and you're going to use it to find A. Okay, you always have to use the row that has everything in it. So if you made a mistake finding gamma, everything is going to be wrong in this one. So just don't make a mistake when you add them up to 180. All right, it does not matter which one you find first. Okay, whether you find A or you find B. Okay, doesn't make a difference. So let's do A first. Okay, so I've got my proportion ready to go. Okay, anyone think they can tell me what's going to go on one side of that proportion? And remember, when you're done, you should have 3 numbers in the proportion and only 1 letter. If you've got 2 letters, you did something wrong. Yep.
One side is sine of 45 over A.
Yep. Sine of 45 over A. Okay, that's my 1 letter, so I can't have letters anywhere else. Anybody tell me what's going to go on the right side? Say it.
Sine of 95 over 4.
Sine of 95 over 4. And when you do the cross multiplying, you don't have to tell me the decimal, but can anybody tell me it's what times what divided by what? Yep.
It's going to be A times sine of 95.
Mhm.
Oh, no, never mind.
Well, you can do that part out. You can, that's just doing the kind of the step in the middle before you get the final
So
answer.
it's going to be 4 times sine 45 divided by sine 95.
Yeah. Okay, so that's going to be your final answer after you cross multiply. Any questions on how I got that? Okay, so just type it in and make sure we get our answer. Again, I'm not going to round anything off till the very end. Okay. So on the test, if you round things off before the end, you're probably going to end up losing points. I'll show you why. 4 sine 45 divided by sine 95, and we get 2.839. All right, now let's say that you decided, you know what, I'm going to do the sine of 45 first, and I'm going to round that to 0.71. Okay, I'm just going to round it off. Okay, don't do this. I'm going to take 4 round that to 0.71. Okay, and I'm going to take sine 95, and I'm going to round that 0.99. It's pretty close to 1. So I'm going to round that up to 1. And now I'm going to take 4 times 0.71 and then divide by 1. Okay. This time, actually it didn't work out too bad. But my answer isn't too far off. I got 2.84. I should have gotten 2.839. So it's still pretty close. Why it came out so close probably is because of that denominator coming out to a nice number. When you start to round, usually what ends up happening is the answer, instead of getting like 2.839, you get like 2.97. Okay, so you start to get a number that's way off. Okay, so just don't round it till the very end. Even though this time you would have gotten lucky if you rounded it and it still would have come out okay. Right, and now let's find b. Okay, so take a second on your own and see if you can set up the proportion to find b. Remember, you want to go back and use a row that has everything in it. And you got to use the row that has b. Okay, so that's the start to how it should look. So, can somebody tell me what they wrote down for the proportion? Oh, Eric? Yeah, what'd you got?
I got sine 95 degrees over 4.
Okay, so sine of 95 over 4. So he went back and used the row that we were given that has the nice numbers in it. I like that. Equals what?
Sine 40 degrees over b.
Sine 40 over b. Now, did anybody have it switched, like the left and the right? Because if you switched it, that's okay too. Okay, as long, if you had sine 95 over 4 on the right and sine 40 over b on the left, that's fine. All right, and Eric, what'd you get when you cross multiply for b is what times what divided by what?
I got 4 sine 40 degrees.
Yep.
Divided by sine 95 degrees.
Perfect. And anybody that got that and typed it in, can you tell me what you got for a decimal? I know it's just a little smaller than 2.839 because beta is a little smaller than alpha. Yep.
2.580.
2.580? Okay. And that's it. So we got all the sides, we got all the angles. We solved the triangle. Okay, any questions on the angle side, angle side angle type? Angle side angle. It's pretty much the same as the first type. All right, and the last type. Okay, this is the type where they're giving you two sides and an angle. So you know a side, and you know an angle. But the important thing here is the angle that they give you cannot be between the two sides. That's a different law. Okay? The angle that they give you has to be one of the two that's not between the two sides. Okay? And the thing that's a little tricky with side-side angle, and this is what's going to end what we do today, and we're going to pick up with this tomorrow, is side-side angle, there's three things that can happen. Okay? And as we start to solve it, I think you'll see something different that happens. Okay, it could be a normal problem, just like we've done with the last two. Okay, you solve everything and there's one answer to the problem. Okay, and by one answer, I mean one answer for A, one answer for B, one answer for gamma. Okay, like the last one. Or, as we're solving it, there might be two answers for everything we have to find. It might not be A, B, and gamma, but whatever the three things are you have to find, there would be three answers, or two answers for all of them. Okay? Or the quickest case is when there's no answer. Okay, we start to solve it, and then we realize for some reason it cannot be solved, and there's no solution. It's not that two answers or no answers are harder or easier. Basically, 2 answers just takes longer. You have to do everything you're doing twice. And no answer, it's just faster. You don't have to do it because you realize really quick there's no solution. Okay, so what I'm going to do today is go through one of the 3 types, and I'm going to show you what to look for if there's a second answer. Okay, I'm not saying whether or not the problem we solve is going to have a second answer, but we'll go through it and I'll show you the test to figure out if it does. All right, so I didn't give you a picture this time, but looking at the table, how can you tell it's a law of sines problem? You have a row with everything in it. And you can tell that it's the case where you have to be careful if you also have a row with nothing in it. Okay? Anytime that happens, you've got a row with everything in it, law of sines. You've got a row with nothing in it. It's the one case that we have to be very careful with. What we're about to do in this problem never happens in any of the other cases. Even when we study law of cosines. Side-to-side angle is the only type of problem that you could end up with 1, 2, or no solution. All right, so I'm going to start to solve it. And this time, I'm forced to find something first. Okay, out of the 3 things I put boxes around, does anybody see what I have to find first? Which one?
Beta?
Yeah, I have to do beta first. Why can't I do C or gamma? I don't have either one. So if you've got a row that's empty, you have to forget about it. You can't use it. Okay? You've got to use rows that have at least everything or at least something in the row. Okay, so forget about the last row for now. So we'll set up our proportion. And this is going to be to find beta. Before I even set it up, does anybody already recognize what's different about what we're about to do? Yeah?
It's an angle rather than side.
Right. We're finding an angle. We've never had to do that before. We've always had to find a side. Okay, so that's something different right away. Okay, I'm going to use my first row because it's got everything in it. Sine of 40 over 3. And John, what am I going to put on the other side? Okay, and could you just tell me like something else with the beta?
Sine of b over 2.
Sine of
Beta.
beta over 2. Okay, so the big difference this time is the variable you're solving for is inside a function. So we've talked about this before, and something we did 2 weeks ago is going to come up here. Okay, so I'm going to cross multiply. 2 sine 40 equals 3 sine beta. And so I don't have to rewrite the whole thing. What would I do to put the 3 on the other side? Divide by? Yeah, just divide by 3. So I'm going to do that in one step. And now my goal is to get beta by itself. So I've got to get rid of sine. Anybody remember what you can do to get rid of a function? It's kind of like if you had squaring and you wanted to get rid of squaring. You need another function that cancels out the one you want to get rid of. Yeah? Okay, good guess, but sine and cosine don't cancel out.
Inverse sine.
Inverse sine. Okay, so I'm not multiplying, I'm taking the inverse sine of what's on the right, and I'm taking the inverse sine of all that stuff. Don't try to get fancy and like cancel anything on the left, just you got to type it in exactly the way you see it. Okay, on the right though, inverse sine and regular sine cancel out. Okay, so let me type that in and see what I get. Okay. Once I type this in, okay, I'm going to know right away whether this is a no solution problem or at least one solution. I won't know if it's 2, but I'll know if it's no solution or at a minimum, one solution. So inverse sine of 2 sine 40. And you know what, I think I have an extra parenthesis. Divided by 3. Okay, this is not a no solution problem. Okay, if it was no solution, I would know right now. My calculator would have said some kind of error, and we'll see that tomorrow. So I know that 25.374 is at least one of the solutions. Okay, so what I'm going to do is write it in the box. But I'm going to write it up a little higher. So if there's a second solution, I'll put it down below. Now we've got to take that, and this is the number we use to check if there's a second answer. But first, any questions on how I got 25.374? All right, so if there's a second solution, take the answer that you just got. In this case, it's beta. In another problem, it might be alpha or gamma. But take the answer that you just got and subtract it from 180. Okay, so let's do that. Let's take 25.374 and subtract it from 180. So if there's a second answer to this problem, that's the second answer, 154.626. So I'm just going to write that down over here. And for now, that if there's a second answer, that's what it would have to be. But what you have to check is see if it's possible to have the angle that you just calculated and the original angle they gave you in the same triangle. Now, what's the restriction on the angles in a triangle? What about 180?
The angles added up can't be more than 180.
Right. In fact, they have to equal exactly 180. Right? Can't be more than 180. So take the angle we just got, take the angle they gave me, and see if they would fit in the same triangle. Okay. My second answer was 154.626. What angle did they give me?
40.
They gave me the 40. Could I fit the 40 and the 154 in the same triangle? No. 154 is too big. So in this case, the second answer doesn't work for beta, which means there is one answer for all three boxes. If the second answer had worked, I would have two answers for beta, two for gamma, and two for C. Okay, but now I don't have to worry about the second answer. So I went through what we just said. So if there was another answer, you take 180 minus what we had, you get 154.626. But the angle that they started you with was a 40. And if you add the two together, it's greater than 180. So that's why the other answer is too big. Okay. So any questions on why I'm not going to use that second answer? Okay, so if there's no questions, now we just finish it up like a normal problem. So the rest of it should be pretty straightforward. What can I figure out now that'll finally give me a piece of information in the last row? Yeah?
Gamma.
Yeah, I can get gamma because I have alpha and I have beta. Okay, so add alpha and beta, that's 65.374. And subtract from 180. Okay, so gamma has to be 114.626. But I couldn't get gamma until I found beta. So you have to do beta. That's the first thing. Then you can do gamma. That's the second thing. And what can I finish up with and find last? C. That's the third thing. You have to go in that order for every problem like this. Okay, so I'll set up my law of sines to find C. I got to use a row that has everything in it. I've got a couple to pick from. which row would be better to pick?
That first one,
The first one. How come?
because this one will be a decimal.
Yeah, we don't have any decimals, right? It's a lot much nicer numbers to work with. So sine of 40 over 3. Sine of 40 over 3 equals. And what's going to go on the other side?
114.626.
Yep, sine 114.626 over
C.
C. Now, even though you're using a number you rounded here, you rounded it to 3 decimal places, so that should be accurate enough. Okay? If you had only rounded it to 1 decimal place, I'd say our answer might be off a little bit, but we should be okay. So C is going to equal 3 sine 114.626 over sine 40. Type that in, and that's your answer for C. Okay, so 3 sine 114.626 divided by sine 40. Okay, so 4.243. Make sure you round properly. 4.243. Okay, is the biggest side across from the biggest angle?
Yes.
Yep. How about smallest side with the smallest angle? Yep. And if you add up any 2 sides, they should always be bigger than the third. So I'm just checking, things look reasonable. There's nothing obviously wrong with my answers. Okay, so any questions on that type? Okay, so tomorrow we'll look at the case that comes up when you get the 2 solutions, and then the case where you get the no solution. Okay, so the homework tonight, it's all odds. Okay, 9 through 13, 17 to 21, and 25. Okay, so all odds. Okay, we'll take a look at that first thing tomorrow, and then we'll finish up law of sines.